sklearnpreprocessingminmaxscale. Description. The min-max scaler in scikit-learn is a preprocessing technique used to transform numerical features in a dataset to a specified range, typically between 0 and 1. This scaling is particularly beneficial for algorithms that are sensitive to feature scales, such as k-nearest neighbors, support vector machines, and neural networks. Inputs. Array: a numerical array representing the dataset with features to be scaled. Feature range: a tuple specifying the desired range for the transformed features. The default is 0, 1, indicating the scaling to a range between 0 and 1. Outputs. Transformed array: the original array with each feature scaled to the specified range. Scalar object: a min-max scalar object that can be used to transform unseen data using the same scaling parameters. Steps. Calculate minimum and maximum. The scaler determines the minimum and maximum values for each feature in the input array. Feature scaling: for each feature, the scaler applies the following formula to transform the values. Scaled value, minimum maximum, minimum new maximum, new minimum. Metrics. Scaled range: the scaled range of values for each feature after applying the transformation. Visualization plots. Box plot: a box plot visualizing the distribution of features before and after scaling. Scatter plot: a scatter plot comparing the original features against the scaled features. Fine-tune parameters. Feature range: this parameter allows you to specify a custom range for the transformed features. For example, you can set it to -1, 1 to scale features to a range between -1 and 1. Uncertainty methods. Not applicable. Min-max scaler does not directly incorporate uncertainty methods. However, the scaled data can be used as input to models that handle uncertainty, such as Bayesian neural networks. Challenges and fixes. Challenge 1: sensitive to outliers. Outliers can significantly impact the scaling, especially if the minimum and maximum values are heavily influenced by outliers. Sample use case that resulted in challenge 1: a dataset containing feature values with one extremely high outlier, causing the scaling to be skewed towards the outlier's range. Fixes to challenge 1. Robust scaler. Consider using robust scaling methods like robust scaler, which is less affected by outliers. Outlier removal: if outliers are deemed inappropriate for the analysis, remove them before applying min-max scaler. Challenge 2: data leakage. Applying min-max scaler on the entire dataset before splitting into train and test sets can lead to data leakage. Sample use case that resulted in challenge 2: scaling the entire dataset before splitting into training and testing sets, then using the transformed data to train a model. The model might learn the information from the test set due to scaling. Fixes to challenge 2. Separate scaling. Apply min-max scaler separately to the training and test sets. Use the scaler fitted on the training set to transform the test set. This ensures that the model is not exposed to the test set information during training.